Data. In order to create digital value, we have to understand how data is structured and how it moves from system to system. Otherwise, we can't figure out if it can or cannot be monetized and if it's ethical. Digital thinkers ask questions about data. How could data sets connect to each other to create new value? What data exists or could exist in our ecosystem? How are we managing informed consent and ensuring our data use doesn't harm our partners or customers? We call this subset of digital fluency data fluency, a shared understanding of how data is disclosed, manipulated, and processed, and the implications thereof. To understand how data works, we need to understand the data supply chain. There are 3 stages of the data supply chain. First, disclosure, whether by a person or a sensor or a system. Second, manipulation, which is when we process data and understand what's possible with it or analyze it in some way. And third, consumption, where data is used by a stakeholder or fed back to users as insight about themselves. At each phase, from acquisition to storage, to aggregation to analysis, to use, to sharing, selling, or disposal, there are key implications and handoffs that have to happen to make sure that ethics are preserved and that the data is still accurate. The first stage is data acquisition. Data is collected from sensors, systems, and humans. Let's use the example of a driverless car or autonomous vehicle as the context for the data's motion, its journey through the data supply chain. In the acquisition stage of data, the car captures raw data from its onboard sensors, like cameras or speed sensors. It's just bits and bytes, and no work has been applied in terms of processing or thinking about it. The next stage of the data supply chain is storage, recording data to a trusted location, which is both secure and easily accessible for further manipulation. Storage is often some version of the cloud, or perhaps a specific server. Sometimes it's a flash drive or local memory on a sensor. But wherever we store data, we need to make sure that we understand how that's going to connect to other systems. In the automotive case, raw data might be stored in an unprocessed form in the vehicle's local memory. Think of it like a hard drive in the car. Aggregate. When we aggregate data, we combine disparate data sets to create a larger data set that's greater than the sum of its parts, often referred to as big data. This is where exponential possibilities begin, but so does exponential complexity. In the car example, the aggregation stage begins when the car gets to its owner's home and syncs, uploading its raw data to the manufacturer's server. Analyze. Once data is collected, stored, and aggregated, it's time to analyze it. We examine data to extract information and discover new insights. We might append this analysis to the original data and/or use it to discard extraneous data. In the automotive example, the company's big data algorithms analyze the raw data from all vehicles in a geographic area and compare it to data from road maps and transit systems. Use. Apply the insights gained from data analysis and use them to make better decisions, which effect change or otherwise help you deliver a product or service. This stage may also involve changing or adding to the data. In the automotive example, collision avoidance and navigation algorithms might be updated across all the vehicles based on the raw data that the auto manufacturer is getting from various cars out on the road. Vehicles then use the updated algorithms to make better decisions. During the share or sell stage, we send data, or insights gleaned from data, back to its source or to third parties. There are significant ethical considerations to take into account in this stage. In the example of the automotive data supply chain, the vehicle maker might make subsets of their data or data-derived insights, like these are the parts of the city that have a lot of traffic, to other manufacturers, map services, or even regulators. This creates a feedback loop to influence the world around us. However, sharing and selling data is the stuff of headlines for a reason. If our driving data is telling someone exactly where and when we drive, do we really want that shared to other manufacturers or map services or advertisers? Dispose. When we think about data in motion and the many distributed and synchronized or federated copies of data out there, it may be nearly impossible to find and delete all instances of the data a user has disclosed or had generated about them. If we can avoid storing the data in the first place, as Apple does by doing face recognition on a user's own phone rather than in the cloud, we may not have as much to deal with. Therefore, it's critical to consider how data deletion and disposal will occur, even if just to prompt us to not unnecessarily store sensitive data in the first place. In the automotive example, disposal of individual data about driving routes could occur after a set period of time, leaving behind only the insights gleaned from it, such as avoiding a certain street during rush hour.